Hello, everyone, and welcome to the very first ever Brighton Cloud meetup. Woohoo! So basically, I started this along with the guys at Silicon Brighton because there wasn't really a cloud meetup group happening, focusing on cloud per se. So I thought it'd be really good, mainly because I'm head of infrastructure at the student room, and I kind of want to meet other people from around Brighton, and this seemed like a really good excuse to get some people in the room or online and have a meetup and chat over beer and pizza or a Zoom call. So thank you very much for coming along. Please continue to do so as we announce the following meetups. First up, massive thank you to our supporters. Tillo have provided very kindly the refreshments that we are all currently enjoying in person. Yeah, definitely check out Tillo. They're smashing it out the park over. You're based in Hove, aren't you guys? Yeah, excellent. Other sponsor this evening is the Student Room, who are very kindly my employer. They are providing the wonderful location in which we are enjoying our time this evening. And also thanks to Silicon Brighton for helping out with all the logistics, or a large portion of logistics. The Student Room, we're the UK's largest, best loved student community. So if you're a student, if you're thinking of going to university, check out the site for loads of advice and tips on what to expect when you get there, how to apply. We cover things like clearing, everything from young people starting their GCSEs all the way through to doing masters and doctorates. So loads of useful stuff on our site. Right, that's enough of the sponsor stuff. Let's crack on with the evening, for which we've got another slide. He says, excellent. So this evening, we're going to have the main talk starting momentarily when I finish waffling on how to build modern data architecture. We'll do a bit of a Q&A, and then we'll cover off future dates, etc. And then on to the main talk tonight, building modern data architecture for analytics on AWS. We've got Mark, Dragos, and Ashley from AWS, who are going to be telling us all about their cool tech. Let's give them a big round of applause.
All right. How is everyone doing? All good? Yeah? All relaxed, had some food, some beers, ready to crack on. All right. So first of all, thank you, Simon, for organizing and inviting us to speak tonight. It's a real pleasure to be here. It's something new, right? After 2 years almost or more than 2 years since the pandemic has been declared. Almost 2 years. It's been a while since we had this kind of presentation in person. So for me, it's, again, it's exciting because working from home every day, can be quite boring. So really happy to be here. Thank you for inviting us. And hopefully you're going to go away with something after tonight's presentation. All right. So I'm Dragos. I'm a solutions architect based in London. I'm a generalist solutions architect, and I'm working for AWS for a bit over 3 years now. And tonight, I'm going to be speaking along with my colleagues Mark and Ashley about analytics in AWS. So just for reference, today's presentation is a high-level one. So I'm going to try not to assume everyone knows what I'm speaking about. So if you have any questions, just feel free to raise your hand or wait until the Q&A at the end. And yeah, we're going to try to answer all of your questions. All right. And also, after the Q&A session, we can network some more. So if you want to casually discuss some of your workloads and anything else, just come to us three. Also, we have Fred. We also have Ben from AWS. They're account managers. They're ready to engage into meaningful conversations with you guys. So that being said, the last thing I want to say before I actually crack on is if you think your organization has a real opportunity to use AWS, no matter if it's analytics or not, just feel free to reach out to us, and we are more than happy to schedule a follow-up call with you in the following weeks. so we can discuss your use cases in more detail. All right. Cool. So tonight's presentation, as you've seen already, it's about analytics in AWS, and more specifically, modern data architectures. So as you might know already, data has been growing at an unprecedented rate. So if in the past we were speaking about gigabytes and terabytes of data mostly, today we start speaking about petabytes and exabytes. So existing on-prem systems, actually we see that can't scale very well to accommodate this large amount of data. Or if you can make them scale, you need to invest a lot of money, and they have the tendency to be really costly. So also that data is not only growing exponentially, but it's coming from new sources. It's increasingly diverse, and we see a requirement that the data needs to be used by any given number of people, as well as any given number of applications at the same time. So these are all challenges for the on-prem systems. Also, it's worth noting that you might have had this experience before, but it's really hard to get meaningful analytics from your data when it's all in silos. You know, you could just see bits and parts of it, but you can't have the whole picture just because it's really hard to join those tables across those various sources. So that's why we like to speak about data lakes in AWS. But what are data lakes? Data lakes are basically a central location where you can store all of your data, and then on top of that, you need to tag all that data and have a searchable catalog that will allow you, so some metadata that will allow you to query the data stored inside that data lake. So customers, we work closely with customers. Over 90% of our roadmap is driven by customers. So we know that customers need to be able to run multiple analytics services against the data. We know that customers need to be able to move the data between various analytics purpose-built data stores and data lakes. We know that customers need a unified way to have governance on top of their data lakes and analytics services. And I think most importantly, we know that customers need to keep costs under control without compromising scale and performance. So that's how we came up with what we like to call a modern data architecture. So some people might think of the integration just between a data lake and a data warehouse. And you might have heard this under the name of a lake house. However, a modern data architecture is not only about that. It's about the ability to integrate all of the analytic systems with the data lake and have the ability to move the data in all directions. Or sometimes not even have to move the data, as you're going to see later. All right. So more often than not, data lakes begin with S3. So customers have been building data lakes on S3 longer than on any other service on any other cloud provider. And today, there are more data lakes being run in AWS than anywhere else. So in addition to data lakes, customers use a combination of services, of analytics services, for different use cases. So some examples would be Amazon EMR, that allows you to run your favorite big data framework on top of EC2. Amazon OpenSearch, which is the successor of Amazon Elasticsearch, for those more real-time use cases. And Amazon Redshift for your data warehousing needs, but without having to commit to like punitive licensing terms. We're going to go more in depth around these services later on. So another thing that customers running data lakes successfully in AWS are using is AWS Glue. AWS Glue is a fully serverless service that allows you to move the data across these various services, as well as have your ETL scripts, jobs, and workflows in just one place. It's one of the most powerful services that is basically the glue that glues everything together. All right, and finally, customers that run data lakes successfully in AWS are using AWS Lake Formation to manage the security and governance of the data, regardless where the data lives. All right, so let's dive in by discussing scalable data lakes. So just to sum up what customers told us they need. They basically need highly scalable, available, secure, and flexible data stores that can handle extremely large amounts of data without compromising on cost or scale. So, as I told you before, the data analytics in AWS usually start with S3. It's the most popular storage service for the data lakes, and there are many reasons for that. There are some exceptions where maybe if you have like real-time data that needs to be queried almost as soon as it was ingested, you might look at OpenSearch or some other real-time oriented services. But 90% of the time, I end up recommending S3 for several reasons. So S3 has, and I'm not praising it for nothing now, it actually has unmatched durability, availability, and scalability. It's a fully managed service that just grows and shrinks automatically, that is highly available by default, and has a decent cost. It has very good security out of the box, compliance, and auditing capabilities. S3 usually has the best price-performance ratio. So if you guys are looking for the best value for your buck, then S3 is the service to look at for your data lake. Also, S3 has the most ways to bring data in. So from physical appliances that can be sent to on-prem to just services that can automate this data replication between on-prem systems and AWS, S3 has the most of them all. Also, S3 has the most partner integrations as well. And there are many third parties that are actually running their analytics solutions on top of S3 and on top of AWS. One last thing about S3 and why should you care about it is that when you store your objects into S3, because by the way, it's just an object-based storage. It's not block storage. You can't install your applications or operating systems on it. You just throw files in it. So, but when you throw those files in it, those are going to be automatically replicated across all the availability zones that are available in one given region. So basically, if you throw your file in S3, that's going to be replicated across various data centers in different locations, all with different internet providers and power suppliers and so on. So that's why it has really good availability, but most importantly, 11 nines of durability, which means you're probably not ever going to lose your data if it's stored in S3. All right. So, however, even though we have this cool service where you can store your data, sometimes setting up a data lake can be a challenge because it can require, manual processes, and you need to monitor your data flow, and you also need to manage encryption keys, and you also need to transform the data and clean the data and put it in partitions and put it in open formats like Parquet and ORC. So there's a lot to do, and if those are manual processes, those could take a lot of time, and most importantly, they will take the same amount of time every time. So that's why we have created AWS Lake Formation. So I've already mentioned Lake Formation before, but I mentioned the permissions and governance system on top of the data lake. Well, Lake Formation actually is also like 60–70% AWS Glue. So, but on top of that, we've added some automations that would allow customers to get started really quickly with it. So instead of you having to do all those manual configurations, we have some templates that you can use to have your data imported from on-prem databases or at other locations. All right. That being said, I'm not going to spend too much time on this slide. I'm a technical person, so I don't like going into CLC stuff. But I think is it's quite impressive to see that these customers are successfully running data lakes on AWS today. And I know they're quite tiny, but I can see here stuff like BMW or Airbnb or Siemens or Goldman Sachs, and they're all using this kind of modern data architecture on AWS successfully today. So yeah, that being said, now I'm going to pass over to my colleague Ashley, who will go over purpose-built data services. We'll come back. Thank you.
Thanks, Dragos. Just doing a sound check, make sure you can hear me as well. So next slide, please. So when you kind of look at the purpose-built analytics services that AWS offer, it really encompasses a few different areas. So you can kind of think around serverless analytics, data ingestion, big data processing, log analytics and full text search, stream processing, and data warehousing. So obviously we've got a lot of different tools to enable kind of the output that you're trying to receive. And as Dragos mentioned, it's all about using the right tool for the right job. So use the data lake as the foundational layer to store all of your data in its pure native format. This can then save time on defining data structures, schemas, and transformations, and then use any of the kind of purpose-built analytics services to use the right tool for the right job to drive the outcome that you need. So like I say, whether it's serverless analytics or whether it's data warehousing, whether it's stream processing, or whether it's a combination of all of them. So just from a high level, if you just look at Amazon Athena is our serverless interactive query service that allows you to derive insights from the data that sits directly within S3 as your data lake. So as a data analyst or a data engineer, maybe I've got data that's being populated in its pure native format into S3. I can then write a simple or complex SQL select star from statement to derive some insights and then connect that to a BI output or a visualization tool that I might be using. EMR I'll discuss in a bit more detail in a following slide, but this is our big data processing framework. So this is really when you think around big data. And when I talk around big data, you often think about the 3 V's of data. So dealing with the large volumes of data, different varieties, so different formats and structures of data, as well as the velocity of data. So how quickly and the speed of thought I need with regard to working with all of that data. OpenSearch will once again cover in a bit more detail. So this is the successor to what was previously called the Amazon Elasticsearch service. And this is really used for a few different use cases. The first is really all around log analytics and observability. And the second is all around providing full text search, hence the name OpenSearch. So you provide a Google-like search over the applications and any kind of unstructured data that you might be working with. Then when you look at the Kinesis and the MSK, so MSK stands for Managed Streaming for Kafka. This is all about real-time analytics. So maybe you want to deal with a vast variety of events in really low latency. So imagine if you're working on a mobile application, you've received an event notification because someone else has used your account. We're all kind of dealing with these sort of event stream processing elements today in our everyday lives. A lot of this will actually be using things like Kafka and Kinesis as the backbone with all of this. And then the fifth element is all around data warehousing. So this allows you to provide complex queries to derive historical insights on petabytes, even exabytes of data. So as I say, it's not an all or nothing approach. You can kind of use the right tool for the right job, depending on the use cases that you're trying to drive, and then kind of only pay for the resources that you're consuming. So let's talk a little bit more about Athena. So as I say, concept with Athena, get your data into S3, derive some insights really, really fast. So you can store your data in open data formats. So this could be Parquet, it could be JSON, or it could be Avro, and then derive some insights directly, just writing simple or complex SQL statements. So you can kind of see the benefits on the slide here. The first thing I wanted to call out is the fact that it's a completely serverless service. So it means that there's no infrastructure to manage and maintain, and you only pay for the queries that you're running. So You don't pay for running any computer infrastructure. The way that Athena actually works from a pricing perspective is a pay per terabyte scanned model. So it's open and standard. So as I say, you can use ANSI standard SQLs, syntax, and supports the open data formats. So Parquet, CSV, JSON, Avro, and other standard data formats as well. The other thing as well to note is that it provides fast interactive performance. So you've got parallel execution on all of this. So you can derive insights from a vast amount of data that you're dealing with. And like I say, if you can think about the old the way that this might work, you might have a strenuous ETL process. You'll denormalize that data into facts and dimension tables and then run the query. Whilst that works and can provide good speed and processing power, sometimes you just need to derive insights really, really quickly. And that's where something like Athena can really help. And then last note is just that it's cost effective. As I say, no infrastructure to manage. You kind of only pay for the queries that you're running. So next service in the toolkit is to cover Amazon EMR. So that stands for Elastic MapReduce. And like I say, this is when you're looking at big data processing. So think around all the V's of big data, right? So volume, variety, and velocity. There's plenty of other V's. There's veracity. There's also a few others. I normally just stick with the 3 ones. So Amazon EMR is pretty much a fully managed environment to have the different big data processing frameworks that you might have been using in the past. So there's lots that support. So you've got Spark, you've got Hadoop, you've got Hive, you've got Presto, you've also got Hoodie. So the thing is, when you think around these sort of data intensive applications, they normally work in distributed systems. So you'll have a leader node and then you'll have a whole bunch of compute nodes. And if you can kind of think about running this in an on-premises environment or a self-managed environment, you can run into a few headaches along the way. So the whole point around EMR is it kind of takes away the operational overhead for you and just allows you to kind of continue building the data processing tasks with the big data frameworks that you know and love and might be using today. So we really see it for a few different use cases. We see it for things like clickstream analytics. We see it for things like event-driven ETL. We also see it used for machine learning as well. So with EMR, you can actually use machine learning frameworks. So if it's MXNet, if it's TensorFlow, if it's anything like that, all of this is actually all supported by EMR as a technology. And we've actually also introduced recently something called EMR Studio. So EMR Studio is an integrated development environment that pretty much allows you to build, debug, and visualize data from your applications using standard Jupyter notebooks. And like I say, supported with lots of different programming languages as well. Few things to note around Amazon EMR as a technology. So like with all of our solutions, it's fast and it's also cost effective. So in terms of the benchmarks, we've seen up to 1.7 times faster than standard Apache Spark 3.0. And with a 40% cost saving as well. The other thing also to note as well is that when I was talking around having Spark, Hadoop, and all of these big data frameworks as a distributed system, if say you want to scale up or scale down based on the throughput and based on the capacity, when you look at an on-premises or a self-managed environment, this can be really, really tricky to achieve. So like I said, the whole concept with it is we ease the operational overhead for you and just allow you to continue using and processing your big data applications. And then similar with everything else, we've got simple and predictable pricing. So pay per second pricing. And then we've got things like spot instances and reserved instances as well to drive the costs down even more. I'll probably run through this one quite quickly in the interest of time, but in terms of the differentiated performance, you can kind of see them on the slide here. I covered it on the last one. So faster performance when it comes to Spark, faster performance when you look at open source Presto, and 80% of cheaper cost. And also we've introduced the Graviton chips. So Graviton chips are custom built processors from AWS. And the good thing about this is you'll see a increase in performance improvement as well as a reduction in cost. So bit of a no-brainer to look at things like Graviton. So I've kind of covered around Athena and EMR. So that covers the serverless analytics and big data side of the house. So OpenSearch is actually something that I'm focused on with a lot of our customers and is really kind of a great tool. This was previously known as the Amazon Elasticsearch service, but in the past few months, we've renamed and rebranded this to the Amazon OpenSearch service. So the way that OpenSearch works as a technology, you can kind of think about it for a few different use cases. The first is around, like I say, log analytics and observability. So imagine you're dealing with data coming in from log data that might be coming in from infrastructure. It might be coming in from applications. It could be coming in from microservices. It could be coming in from wireless devices or any other connected devices. OpenSearch is a technology that allows you to ingest, correlate, and visualize all of these logs to derive insights really, really quickly. So it's a really powerful tool for dealing for any kind of logs that you might be dealing with. The other use case that I often see is full text search. So imagine you want to provide a Google-like search over applications and websites. So you can pretty much ingest anything into OpenSearch as a technology. So this could be PDF files, it could be web pages, it could be application data, and then provide a search experience over this data. So a lot of our customers, what they're doing is, if you take an e-commerce platform, you might have users that are searching through to find different products within that. A lot of these capabilities are actually powered by something like the OpenSearch service. The other thing that you can also do from that is internally, you can look at things like relevance between products. You can look at ranking them. So when you kind of search through something, you'll have the most relevant ones to your users at the top and the least relevant ones at the bottom. So like I say, a really powerful solution, not only for log analytics, but also for providing full text search as well. Similar kind of thing when we look at why we're seeing customers move to fully managed solutions. It all comes back to the fact that we take away that operational overhead for you and just allow you to kind of build these log analytics and full text search solutions. So like I say, it's fully managed. So we take care of upgrades, patching, high availability, scalability, all of this sort of stuff. And then you can kind of use all of the same open source APIs that you might have been using with previous versions of Elasticsearch. And it's also cost effective. So we've got kind of ultra warm and low cost storage tiers to once again drive down costs with regard to your data. So if you take a look at the log side of the house, a lot of this is maybe time bound. So you might want to keep logs for 30, 60, 90 days. Something like ultra warm or cold storage can allow you to maybe offset the older infrequently accessed data into those tiers, and then you pay a lot cheaper cost with regards to the logs or the documents that you're working with. So yeah, that's a little bit around OpenSearch, success to Elasticsearch. So OpenSearch 1.0 is now out. Doesn't mean that we'll stop supporting previous versions of the Amazon Elasticsearch service, and we'll never kind of force an upgrade upon you. So let's just talk around the OpenSearch project as a whole. So it's worth noting that this is a 100% open source community-driven project. So this is licensed under the Apache 2.0 license. And then what we also do is we offer a lot of the enterprise grade capabilities along with that. So when you look at security, advanced capabilities such as alerting, SAML integration, performance analyzers, all of things like this, we include all of this in there without an additional licensing fee to pay for it. And then, like I say, it's a really community-driven project. So as an OpenSearch customer, if you are one, you can actually contribute code to this and keep evolving it as the project continues over time. So next one to cover is stream processing. And there's really two services to cover for this. There's Amazon MSK, which is managed stream for Kafka, and there's also the Kinesis family. So for those of you who don't know or haven't heard of Kafka, so Kafka was derived from a project with LinkedIn and then was donated to the Apache community a few years later, and has really become the de facto for stream processing and event-driven architectures. So imagine you've got applications, IoT devices, other bits of infrastructure that are emitting a vast amount of events. you want a way to kind of ingest all of these events in as near real time as possible. So you can use something like Managed Stream for Kafka in terms of doing this. Similar thing, if you actually look at Kafka, Kafka is yet again another kind of distributed system, which means if you're running this in a self-managed environment or in an on-premise environment, you can face a few headaches and challenges along the way. So achieving high availability, getting actually set up initially can be quite hard to achieve. Achieving integration is typically hard to achieve. And this is why we've created Amazon MSK, because once again, similar with the other technologies, it takes away all of that headache. So it's fully compatible with Apache Kafka and uses the same open source version that you might be using today. And then it's fully managed, so you can focus on creating applications and not actually having to manage Kafka as a distributed system. You can also use Kafka with Kinesis Data Analytics, which I'll cover in a following slide. And then you can use a lot of the other Kafka ecosystems. So the Streams API, Kafka Connect, the Schema Registry, all of these sorts of tools and technologies as well. It's a highly available and a highly secure service. So like I say, Apache Kafka become the de facto for stream processing. But now we've got Amazon MSK to basically have a distributed processing like Kafka, but just have that in a fully managed environment. The next option we have, or another option we have when it comes to stream processing, is Kinesis. So similar with something like Kafka, this will allow you to easily collect, process, analyze data and video streams in real time. So when I was talking about MSK on the previous slide, that is quite similar to Kinesis data stream. So effectively the similar technology, except Kafka's open source, Kinesis is not. Kafka has the concept around topics and partitions. Kinesis has the concept of streams and shards. Effectively the same tool that you'd use for real-time web and log analytics. Maybe it's streaming ETL, maybe it's messaging between decoupled microservices. These are the sorts of use cases that you might use Kinesis data streams or MSK for. When you look at something like Kinesis Data Analytics, this allows you to apply analytics against the stream process of data you have in real time. So maybe you're ingesting data in real time, and then you want to apply an analytical query or an aggregation on that data. You can do that using Kinesis Data Analytics, either using open source Apache Flink or using the SQL API. And then finally, when you look at Kinesis Data Firehose, this provides an easy way to load data into different data stores that you might be working with. So you can in real time ingest data from an application and then load that directly into S3, into Redshift, or into Amazon S3. So maybe in real time, when Dragos was talking about the data lake approach, you can maybe ingest data from in real time using Kinesis Firehose, ingest that into S3, use Athena to derive some insights really, really quickly, and do that with, like I say, without actually having to manage any of the infrastructure whatsoever. So I'll just do a quick time check. I'll probably have to rattle through this a bit quicker than expected. So, so Amazon Redshift. So this is our cloud-based data warehousing tool that allows you to run SQL queries against up to petabytes worth of data. So it allows you to analyze all of your data. So has integration with your data lake in S3, as well as kind of purpose-built database stores like Amazon Aurora. Similar thing, provides performance at any scale, so up to 3x performance with regard to other cloud data warehouses, and at a 50% cheaper cost as well. In terms of the Redshift architecture, this is known as a MPP, so massively parallel processing system, and is really designed of what we call leader nodes and compute nodes. So if I start off at the top, you've got your SQL and BI tools that you can connect to Redshift using a JDBC or an ODBC connection. Or if you're using other programming languages like Python, R, or anything like that, you can also use the data API. And then when you look at the leader node, this kind of will gather execution plans, and then the compute nodes will actually do all of the execution in terms of running those queries and then pass them back to the leader node. It's not showing on the slide here, but I don't know why it's not. In the middle should be Redshift Spectrum. Redshift Spectrum is a tool that allows you to query the data that sits directly within S3. So think around it as having like-for-like compatibility, like-for-like functionality with something like Athena, but directly within the Redshift ecosystem itself. And like I say, you've got integration directly with S3 as a technology. Oh, there's Spectrum there. It's a bit lagged. In the interest of time, do you want to maybe skip on the Aqua slide? And then I'll cover data sharing quickly. So data sharing pretty much will allow you to share live data across Redshift clusters without a strenuous ETL process. So imagine you could have one Redshift cluster for ETL. Maybe you could have one Redshift cluster for data science workloads, and maybe you've got another Redshift cluster for data engineering workloads. You can easily share live and consistent data between all of these different workloads as well. It often works with like different personas. So if you've got a finance team and also a marketing team that have the different data models but want an easy way to share data, then you can use something like data sharing in terms of achieving that. And then we've got another tool, Redshift ML. It's not actually in preview anymore, so this slide needs updating, but this will actually allow you to run machine learning models directly within your Redshift environment. So the way it'll work, you can collect and load data into your data warehouse, and then use a create model command in Redshift itself, and then use a tool like SageMaker to train and deploy that model. SageMaker is another tool we've got, which is for building, training, and deploying your machine learning models at scale. And then you can deploy that model using Redshift again, and then you can then query that data using Redshift. So think about Redshift not only as a data warehousing tool these days, but actually you can run some machine learning tasks in there as well. And then just a quick view around all of the other different areas. So Redshift is probably one of the most innovative products within the AWS Analytics ecosystem. If I look at where it was 2 years ago when I joined AWS to where it is now, it's just come along leaps and bounds. So here's just a view of all of the different capabilities we've got. So data lake export, federated query, data sharing, and machine Redshift ML we've kind of been through, but there's a whole plethora of different capabilities and functionalities that we've got. So if you haven't looked at Redshift in a while, take a look at it again, because there's a lot that's been brought out, and there's still a bunch more that's coming out on the roadmap. So we've kind of covered a lot of the data analytics element, but the other thing you've got to think around is how you ingest, catalog, and govern your data, and that kind of provides a nice segue on to Mark to discuss Glue and lake formation.
All right, so good evening, everybody. So my name is Mark Dobby. I'm another of the solution architects based here in the UK. Dragon has already talked a little bit around this data lake concept. So what we're doing with the data lake is we're breaking down our data silos. And at the heart of our architecture, we have this S3-backed data lake. All right, so we need to be able to run these different analytics services against that data. And to facilitate that, we need to be able to seamlessly move the data between the different services and our data lake in any direction. And when we talk about direction of travel, we're generally talking about 3 patterns. So firstly, inside out. So potentially we've maybe got our clickstream data going straight into our data lake. We need to copy a portion of that out to our Redshift data warehouse, and then we can generate maybe daily business reports from that data. The next pattern is outside in. So we might have, say, shopping cart data sitting within our DynamoDB database, and we want to combine and join that with historical data sitting within our data lake, and then we can, once we have that combined, we can then maybe do processing around building recommendations. So maybe using a service like Amazon SageMaker. And then the third pattern is around the perimeter. So Ashley talked about open search being great for product catalog search. So maybe we have our catalog data actually sitting in Aurora, our RDS, our relational database service, and we need to copy that across from Aurora into our open search service. Okay, so to enable this seamless data movement, AWS provides a number of tools and services, some of which you've already heard about from Dragos and Ashley. So in terms of ETL, we've got AWS Glue, visual data preparation to try and reduce that burden of preparing data for your analytics projects. We've got AWS Glue Data Brew, data replication. We're going to take a quick look at something called Glue Elastic Views. And then for moving data between your data warehouse and your data lake and back and forward, we've got a couple of features and services that we'll cover as well. And then lastly, for federated queries, so the ability to be able to query across multiple disparate data sources, then we'll look at an option with both Redshift and with Athena. Okay, so let me kick off with AWS Glue. So Glue, it makes it easy to discover and prepare and combine your data for analytics, machine learning, and application development use cases. So you can start analyzing your data within minutes rather than potentially weeks or months. And it supports a variety of data sources. So these could be within AWS, they could be data sources you still have on-prem. And the type of data could be batch data, or it could also be streaming data coming from Kafka, MSK, or the Kinesis service that Ashley mentioned. Glue also helps to simplify ETL workflow orchestration, so you can easily run and manage thousands of data integration jobs with Glue. And there's a visual tool, Glue Workflows, which allows you to build dependencies between the different components within your workflow. And as with a lot of the services that we discussed tonight, it's serverless, so there's no servers to manage, and you pay only for the resources that your jobs consume. And then the last point in this slide around Glue is around simplification of development. So with Glue, there's a visual development tool called Glue Studio, which we're going to look at in the next slide. Okay, so this is Glue Studio, our visual development tool. So it's targeted really at users of all levels and allows them to create Apache Spark jobs to then run on the Glue serverless Spark-based ETL platform. And it allows authors to visually code these jobs using these components that you can see as kind of boxes and arrows type interface here. But it's not just a visual development tool. It's also your single pane of glass for monitoring all the jobs that you're running within Glue, whether they've been developed through Studio or maybe through some other environment or code editor. Okay, so there are cases though, and there are roles in the data integration world, such as data analysts and data scientists, where they're maybe much less comfortable in writing code. And it's not really their core job. Their core job is in understanding the data and deriving value from that data. So really, they don't want to be, spending hours and hours writing ETL scripts. So Data Brew is a completely no-code solution. It allows analysts, data analysts, and data scientists to clean and normalize data with this rich user interface. It has a library of over 250 built-in transformations. And as you're kind of developing with these transformations, you're building up a recipe of transformations, which you can then run within Glue Data Brew. And then Glue Data Brew will scale to work on your large data sets. It's another serverless solution. One of the nice features about Glue Data Brew as well is you can run a data profile job on your data. So that's a kind of data quality assessment. And it will identify 40 plus data quality statistics about your data set. So things like data anomalies, missing values, data duplication, and so on. Okay, so Glue Elastic Views is our one of our options for data replication. So the use case with Elastic Views is that maybe you're developing a new application, and with that application, you actually want to combine data that sits in multiple different data sources, and often that involves lots of development to kind of access and replicate and keep that data up to date. So with Glue Elastic Views, what you can actually do is you can actually create a materialized view or a virtual table across your different data sources. And you can do that simply using a familiar SQL code to build that materialized view in your target data source or database. And once you have that materialized view established, then Glue Elastic Views will continually monitor the source databases for any updates, and then it will refresh your target database within seconds. So again, it's another serverless solution. It will automatically scale up and down to accommodate your workload. And one thing to note as well, just around the update process, where maybe the model changes in your source database, then Elastic Views will proactively alert the developer to say, hey, look, the model's changed. You may need to take some action in your source, or sorry, in your target database as well. Okay, so shifting tack slightly away from Glue, this is so I'm going to cover a couple of features around moving data between your data warehouse and your data lake. So I actually already touched on something called Redshift Spectrum, which is this diagram here on the left. So Redshift Spectrum allows you to extend the analytical power of your Redshift cluster beyond just the data stored on the local disks in that Redshift cluster. So you can potentially scan or query exabytes of data that's sitting within your S3 data lake using Redshift Spectrum. So you're directly querying that data just using Redshift SQL commands. So if you're already using Redshift, then it's a very familiar toolkit to be able to then access that data in your data lake. And it will scale to any volume of data. And you pay, as with some of the other services, you pay for what you use. And in terms of what you're paying for the volume of data scanned. So it's always important to think about how your data is structured in terms of partitions within your data lake. Just back to that slide again, please. Thank you. So the service on the right-hand side, or the feature on the right-hand side, is something called Redshift Data Lake Export. And this is for taking data back from your Redshift data warehouse back into S3. So you may, for example, have done some transformation on that data within Redshift. You then want to export or copy that data back into S3. And rather than having to build a kind of full ETL process to do that, then Data Lake Export lets you do that again just by running some SQL commands. And then by running that, the result of that SQL query is that the data is exported back into your S3 Data Lake in an Apache Parquet format. It will also automatically update your data catalog in your analytics architecture. So that's going to be your AWS Glue data catalog. And that then makes it available to services such as Amazon Athena and Amazon EMR to then query and make use of that data. Okay, and the last section on data movement is around federated queries. And as I mentioned, this is both covering Amazon Redshift and Athena. Right. So we start with Redshift. So with Redshift, the federated query mechanism allows you to incorporate, say, your operational databases. In the case of Redshift, federated query, that's going to be PostgreSQL and MySQL running in Amazon RDS or in Amazon Aurora. So the use case might be that you want to incorporate some operational data into your business intelligence reports. So federated query allows you to do that from within your Redshift cluster. And then with Amazon Athena, the concept's very similar. But with Amazon Athena, Amazon Athena extends to a few additional data sources that are listed down on the bottom here. So Amazon Elasticache for Redis, Amazon Document DB, Amazon DynamoDB, and HBase in Amazon EMR. And it's based around Athena data connectors. And these are pre-built. And they're provided as Lambda functions. But if you do have additional data sources that aren't supported or covered by those pre-built connectors, then you can actually build your own connectors as well. And you would do that using the Athena Federated Query SDK to do that. Okay, so that covers everything around the seamless data movement capabilities that I was going to talk about this evening. So moving on to unified governance within this modern analytics architecture. So when we talk about unified governance and governance in general, we're talking about the ability to authorize and manage and audit access to your data lake. So now you've centralized all your data in here, and we have all these different services and users that want to access that data, then this can be a big challenge to kind of police that access. What we're looking to do is we're looking to kind of centralize that management of the security and access control and audit trails. Without a centralized system, we'd have to do that in every service around the outside. And this becomes a very kind of complex and manual process that can be very error prone. So the solution to this problem is AWS Lake Formation, which I believe Ashley or Dragas already mentioned this evening. And this provides a centralized location for you to apply and enforce those access controls to all of the services around outside that are trying to access your data. Okay, and in terms of lake formation itself, so lake formation allows you to build. Just click on to the next slide. Thank you. So lake formation itself allows you to build this secure data lake in days. And it uses many of the capabilities of AWS Glue to move, store, and catalog your data faster. So it also, as I mentioned, simplifies security management. So for example, with lake formation, you actually apply column level permissions to your data in your S3 data lake. So you might have PI data that's maybe sitting in some of your data files, and you need to control which services have access to that data. So you can do all that from a central location, and the tool to do that is lake formation. And lake formation also provides self-service access to your data. And this is very important so that users can discover the available data sets within your data lake rather than having to pester other teams to locate that data and then get access to it. So the data catalog describes what sets are available and who has access to those sets. Okay, and then just closing out this section on unified governance, then I just wanted to highlight a new feature that's in preview with lake formation. And this is something called govern tables, and just highlight kind of three of the features within govern tables. So firstly, govern tables provides this ability to have ACID transactions within your data lake. So it's the same concept as transactions in a traditional database. So, for example, user one is running a query with Amazon Athena to maybe aggregate sales data. And then user two is actually uploading more data into that same area in your data lake, adding more partitions. So while that transaction is running, then that will protect that user one's query from then picking up those new data files that are coming in from user two. So you can get that consistency with the queries using the ACID transactions. And the second one here is, we're just backwards, thank you. Optimization acceleration. So the use case here, if you think about the streaming data use cases that Ashley mentioned earlier, then as that data arrives into your S3 data lake, it actually consists of a lot of very small files. And they don't really benefit your queries and analytics in terms of performance. So this storage optimization will automatically compact those small files and help to improve the performance of your analytics processes. And then just the final point here is on something called time travel. This is effectively versioning your data within your data lake. So you can query a table within your data lake as of a previous point in time. So you might want to do that maybe if you're trying to reproduce an experiment on your data from a certain point in time. There's new data being added in since. So you can run, say, a SQL query to say select star from table A from this point in time. So that then allows you to do that reproduction of those experiments or actions that you've done previously. Okay, cool. I'm going to stop there. I'm going to hand it back to Dragos just to wrap up with final slides.
All right. How are you doing? Still hanging in there? Yeah, I know it's late. You've had a busy day at work probably, so I'm going to try to wrap it up quite quickly. I think my last slide will take like 14 more minutes. Is that okay, or should I speed up to the Q&A? All right, cool. All right, so I'm gonna try to keep it interesting as much as possible. So I'm gonna be talking about two last topics before we wrap up. It's gonna be business intelligence and also machine learning in AWS. So in the old days, you might have heard of BI tools like Oracle or BIE, right? Where, it's kind of a traditional enterprise report building BI tool, and it usually needs IT expertise and developers, right, to build those reports for you, which are mainly static reports, right? So that were the old days, and then we've had vendors like Tableau that came in to change a bit the game. And by the way, Tableau is an AWS partner, and we work really close to them. So what they brought to the table differently was that they made the dashboards interactive. So they brought the ability to filter, sort the data, right, and play around with the data. And also they've made it a bit more self-service. So you won't rely necessarily on developers or specialized IT resources to build those reports. And then we've seen that customers wanted to be able to share their dashboards, sometimes with like just tens of users, internal users within their organizations to see those BI reports. But sometimes customers are asking us for the ability to share those dashboards to tens of thousands of users and also external users from the organization. Another thing that we've seen in the market is that some ISVs, for example, they started embedding dashboards in applications, so they would make those available easily to customers. So one example here is Blackboard, which is an independent software vendor selling their solution on the AWS Marketplace. And they provide dashboards for school administrators to see how efficient is their online curriculum. So to do this, they didn't only have to embed these dashboards into applications, but they also had to cost effectively scale this for thousands of customers at the same time. And they wanted to find a method to, not pay for the capacity they won't use. So inspired by all these trends, Amazon has created a cloud-native BI tool called Amazon QuickSight. So QuickSight is serverless, so again, fully managed. It seamlessly scales from tens to tens of thousands of users without any infrastructure management or capacity planning. So QuickSight has all the benefits I've presented to you in the other slide. So it's modern, interactive, it's self-service, and also has capabilities that allow you to easily embed it in your own applications. And also it has ML-powered insights. So to give you a sense of the scale that QuickSight can operate at, one of the customers using QuickSight today is Amazon.com. So the last time I checked, there were like around 425,000 users that were using QuickSight in Amazon.com. However, we noticed that those users are not using those at the same time. So that's why a user priced or capacity price licensing type wouldn't work for such a big scale. And obviously, though, imagine the amount of infrastructure you'd have to manage for 400,000 users. All right. Some of the cool ML-powered insights that QuickSight has don't require you to have any AI or ML experience at all. Some of those are auto narrative generation, which is basically you have a dashboard, a graph, and then if you enable this feature, it's just going to generate a narrative, so you can more easily explain it to whoever is listening. Also, another interesting feature is forecasting. So if you have, let's say, sales revenue from the last year, you can just do some forecasting for the next 2, 3, 4 months. And even if you can do it backwards to see what forecasting would have predicted where you actually have data to see how well it works. And the last example I want to give here with ML-powered insights is the coolest thing with QuickSight, in my opinion, which is QuickSight Q. So QuickSight Q enables users to ask ad hoc questions about their business data in a human-readable format. And you usually get answers in seconds. So the way it works, you just go to the QuickSight Q search bar and you ask your question in pure English. So QuickSight Q then, it doesn't, as the user starts typing, it's automatically, recommending words and business terms. So it has auto completion. It does spell checking for you. And even stuff like acronym and synonym matching. So you don't need to remember those business terms, and you don't need to worry about typos. So some of the questions that you can ask QuickSight Q sound like, what was the revenue for product X last month? Or what region had the highest revenue in the last couple of weeks? And because QuickSight Q comes with pre-trained data from various industries, such as sales, marketing, HR, energy, insurance, pharma, and more, you can also ask very specialized questions like business jargon using QuickSight Q. And some examples here would be, how is my sales tracking against my quota for the sales organization? Or what is the conversion rate across my campaigns for marketing? QuickSight Q also improves with the user interactions. So for example, when QuickSight Q doesn't understand the question, if, for example, a user would use something like my products in a question, give me some data about my products, then the users are going to be prompted with options, for the user to choose from, selecting what products are they referring to, and then it's going to remember their answer. So I personally think QuickSight Q is going to make it much easier for BI end users to get answers to those important business questions. All right. Now, I'm going to jump real quickly from BI to machine learning in the interest of time. And here, I know there are lots of services. I'm not going to bother you to have you read all of them. But what I like to do when presenting this slide is I like to divide it in three main categories. So we have three main types of ML users. We have the all-time experts, the best of the best. We have the all-time beginners, just like myself. And we have something in between that want the best of both worlds. So for those who have little to no AI and ML experience, we have this category of AI services. So some examples here are, for example, Amazon Poly that can transform text to speech for those accessibility use cases. We have Amazon Transcribe that can transform audio to text if you want a transcript for your calls or a transcript from your audio files. We have Amazon Comprehend if you want to do a sentiment analysis. You want to see how happy or unhappy are your customers in general. We have Amazon Recognition if, for example, you want to see what objects are in your photos or videos with a certain amount of probability, of course. We have Amazon Lex if you want to integrate the chatbot functionality in your own applications. We have Amazon Personalize. So if you want to give recommendations to your users, those could be something around the line. If user X liked movie Y, then the other user might like the same movie, right? Then we have stuff like Amazon Forecast and Amazon Fraud Detector, which do with what the name says they do most of the times. Also, we have more specialized AI services for various industries. So for example, for healthcare, as well as for medical. And also we have AI services that are specialized on IoT, sensors, and electrical equipment, if you have factories, as well as analysis for your contact centers, reviews of your code, and many more. So as you can see, there's a plethora of services that you can use without having any AI or ML experience. Now, moving on to the second category I'm going to speak of, and those are basically data scientists that have the ML experience and have been playing with ML before, but they probably don't want to manage their own infrastructure or to install their own ML frameworks and customize those frameworks. So for those, we have Amazon SageMaker, which basically allows you to clean your data, choose your algorithm, build your model, train your model, deploy it for inference, and even tune it afterwards to improve it in a fully managed fashion. So SageMaker offers you the full pipeline without having to provision one server or to install or secure operating systems or AI or ML frameworks. And then for those real experts and those who actually need access to the underlying operating systems and data, and they need to customize things for their specific really niche use cases, we have the deep learning AMIs. So the AMIs, or Amazon Machine Images, are those images that you can use to create virtual machines in AWS or EC2 instances. And they have AI and ML frameworks like TensorFlow, MXNet, PyTorch, and more already configured into it. So you can easily just take that image, launch a server with it, and then when choosing the instance type, we also have instance types that have been created with AI and ML use cases in mind. And those, for example, are instance types that have GPUs attached. All right, cool. So I think I'm going to stop now for machine learning services, but if you guys have questions, we can speak about it more later. So to wrap it all up, what we learned today. In my opinion, a modern data architecture in AWS should be able to allow you to quickly get insights from all of your data to all of your users. And it should do so in a way that is not compromising cost, scalability, or performance. So the modern data architecture we've spoken about today is meant to help you rapidly build a scalable data lake. Then it should help you use a broad and deep collection of purpose-built analytics services to analyze this data. it should make it easier to move data between the data lake and the purpose-built services. It's meant to ensure compliance via a unified and secure way to manage, monitor, and access your data. And finally, it should allow you to scale your system without compromising performance or cost. And one last thing before we conclude, you don't actually need to move data that much, because almost all of the AI and ML services that I mentioned, almost all the services that you see here, especially Redshift, Amazon EMR, SageMaker, they work directly on top of S3. So you don't even need to move the data across anymore as much. So yeah, tens of thousands of users are running their data lakes in AWS. So if you're interested in following their lead, just let's schedule a call in the following weeks if you think there is an opportunity for your organizations to use AWS. And yeah, we're gonna help you with your journey in AWS. Thank you so much. And yeah.
Can we just give a quick round of applause to our lovely speakers? Thank you very much, guys. That was absolutely awesome. On the next meetup, which we're aiming for Thursday, the 13th of January. As a quick recap, as a quick reminder, obviously this is a brand new meetup. So if there is a topic that you would like to see a talk on, if you would like to give a talk, if you know someone that would like to give a talk, please do give us some feedback. You can reach us via the meetup page. You can get in contact with Silicon Brighton, or you can come and talk to me afterwards. Obviously, it's a meetup for the community around Brighton. So it's going to be driven by what people want. So let us know. Otherwise, you're going to land whatever I get. Thanks again to our sponsors, Tillo, for providing all the refreshments, and to the Student Room for providing our venue, and to Silicon Brighton for supporting us with all the wonderful AV technology and enabling us to beam it to people's living rooms and home studies and wherever else they are. And go and check out Tillo and the Student Room. And I think I'm going to stop talking now. Thank you very much. Goodbye to everyone online. We'll see you in January.